Yes, my name is Franz Hirtenfelder. I've been working at CST for quite a while as application engineer, enjoying a lot of questions from the customer side, supporting them. And now I'm at the OEM at Dassault Systems and trying to help with EM application in this area. OEM means car manufacturer mainly. My talk is about RF co-site interference. I would like to give you an introduction to that a little bit, and then I show you the workflow live, what we need, what are the prerequisites for this, what are the results we can expect in the short summary. Here is basically the idea of the definition of the interference. So you have a couple of RF systems which are typically co-located. Interesting is the fact that these RF systems or the interferer does not necessarily to be an RF system. It can be any other subsystem which is not intended to be an RF system, but due to higher harmonics it might happen that they interfere with each other at certain frequency bands. Most of these RF systems are co-located, like on a mobile phone. Or in a PC board, PCB of a computer. If there is some interference, it doesn't mean that the system is malfunctioning. It's maybe degrading the performance, like lower speed in uploading a link or something like that. So basically we have a transmitter and it transmits, and we have a receiver, so this is the intended signal. And the way to describe this is normally by signal to noise ratio. So this means the wanted signal to the unwanted or noise ratio. This signal to noise ratio depends on a couple of parameters like receiver sensitivity, of course, the power from the transmitter, the antenna gain of both sides, and some path losses. Looks like a Friese equation is involved here a lot. Normally you have more than one receiver or more than one transmitter all around my victim, which is my receiver here. And as you can see here, also bus line can be interfere with with my receiver here in this scenario. So these are typical scenarios. As an example, I show you here Wi-Fi signal, how this looks like. So you can see the blue line here, which is the sensitivity, working very sensitive in a certain channel. Then you have the level of your actual signal level, which is about maybe 44 dB or 50 dB, something about like this. Like this, and then you have a signal to noise ratio of 44. So the bigger the noise ratio, signal to noise ratio, the better the system is working. And then you have some interference like GSM, which is probably or luckily out of band. You might have Bluetooth, which is probably working in the same band, reducing your signal to noise ratio. And you have USB, which is normally wideband and is even reducing your signal to noise ratio even more. So the closer you're getting, the higher the probability of malfunctioning. Co-site interference, some examples. It comes from the military.